Python06 algorithmic thinking and coding. Sorry for not displaying my face, but I'm not in a condition to be seen. It happens. The early morning. Okay, this lesson will be short, I hope. We will start putting everything we have learned up to now into a very practical example. Building a search engine. Yes, you read right, or you heard right in your case. We will build a search engine like Google. This is our final goal. I don't know whether we will arrive, but at least we will start to build pieces of a search engine. I take for granted that you know what a search engine, how a search engine works. Otherwise, please tell me clearly the name of all your professors of computer science, that I will spit in their eyes. Okay, search engine like Google. Okay, before you do a search, goes through the web, takes any web page it finds, okay, searches all the links that are contained in the web page, and follows those links to be able to discover other web pages. This is how a search engine indexes the web. So, starting from some web pages, follows all the links contained there to discover other web pages. This is the basic work. Clearly, there is much more. However, this is the thing we will focus now. Don't worry, it is just an excuse to do a specific and clear project. Otherwise, I will give you tons and tons of examples taken randomly somewhere from here and there. So now we'll have a specific goal. You will not. It doesn't have to be so performing as Google, and maybe we will not be able to finish. I don't know. Okay, so the very first thing we'll have to learn is how to get a web page HTML code. You will say, HT what? Okay, so now again, tell me who were your computer science professors. Okay, each web page, let's say for example, my web page. Okay, this one. Okay, you see it in this way, but behind, it's not written exactly like this. Behind there is the HTML code. Let's see whether it's not the fault of the Mac, whether Chrome let me see it. Developer tools, no. Let's see. Yeah, this is the HTML code. This is part of the HTML code. It's a part of it. Okay. Do I have something better? HTML, here it is. No, body. Where is the rest of the HTML? Sources. Okay, this is the full HTML. Okay, can you see? The content is here if you are interested in advanced data analysis. So the content is here, but you see this kind of tags to make things big, bold, put hyperlink or whatever I need. So for example, this span class equal titoli 1/mezzo, okay, which will put, for example, this thing here. What is it? This thing here. To make this thing here, I can see this corresponds to this one. Okay, so there are this kind of tags inside the code which will help you with the formatting or with a hyperlink. For example, let's see a hyperlink, or with the images. Here, this hyperlink here at the very beginning. Here, advanced computer. Okay, this one, this hyperlink. Okay, advanced computer skills. Okay, so you see the text with in the middle these tags, that are called tags. They start always with the symbol here and then always with this one. Okay, so we will have to get this part of the web page. So this thing here, which I call the web page source. Let me now close the developer tools. Okay, how to get the web page source inside Python? Well, take this thing as magic. Okay, import request. Request is an additional package of Python. Okay, page equal request get whatever. print page content. So inside page.content, content is a sort of method for page. Inside page content, you find a big string containing all the, let's see, it takes a while because the web page of the university is pretty long, and this is the web page of the university. Can you see title? Okay, blah blah blah. The web page of the university contains many more text than me. The Free University of Bolzano is located. Meta property description. Blah 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 blah. Tons and tons of things. Okay. Now inside page content, I have the web page of the university, the source of the web page of the university. Okay, so if I take this line as magic, then I will explain later on what does it mean to import. Inside the page content, you have the web page HTML code. Okay, from this HTML code, I want to be able to get a link, to get out all the links. Let's see whether we find one. Here, this is a link. When you click on research, you will go automatically to N home research, www.unibz.it English home research. This is a link. The link have the feature that they always start that there is something as href, which means hypertext reference, equal quotation. So the link starts with this thing and ends with another quotation. Okay, so now we develop a tool which will go through the web page, finding this thing, okay, getting everything after it, so starting from here, up to the next quotation. Okay, so let's see. We'll write a procedure, get link. The procedure takes P, which is the page, and N. Okay. Okay, N is where the procedure has to start finding the link. But if you just do like this, you will be able to get the first link. I want to get a link starting from position N. Okay, so let's write a comment. This procedure gets a link in web page P starting from position N. Okay. Now, how do we have to do it? Let's see. So we have to use find, obviously. Okay, so we have already the web page in P. So from probably p.find, okay, href equal. Sorry, it's better to use the single quotation. Href equal. Okay. Okay. Starting from character N. In this way, we'll find the first occurrence of href equal quotation, okay, starting from character N. Okay, where do we put it? Let's call it start position, and let's put it here. Okay, so inside the start position, we have the beginning of the link. Okay. Now, it may happen that we don't have any link, so if start position equal -1, return. Well, in this case, we return -1, for example. Okay. I want to return two things. Tell us where the link finishes and the link itself. So return nothing. Well, let's do it like this. If start position is larger than -1. So if it exists, and then we'll analyze the situation when it doesn't exist later on. So if it exists. Okay, what do we do if it exists? If it exists, I want to return the position of the link, so the start. Where the link finishes, the end of the link, and the link itself. Okay. So let's first get the link itself. Start position +6. Why +6? Well, because look, I get the position of H, but H is not where the link starts. So I make my +1, +2, +3, +4, +5, +6. Okay. Okay. So this way I get the real starting position of the link. Okay. Now I have to get where does it end. So maybe with p find the closing quotation starting from start position. So I search for the closing quotation. Okay, so I'm here. I start from here and search for the closing quotation. So you will find this one. Okay, and this is the end position. Okay, or better, the end position is this one -1. So here the last character. We indicate the last. Okay. You can also avoid putting -1, but you have to remember that get the last character. Now, the URL, the link, or you prefer link, equal a p from start position to end position +1. Okay, it's silly to put -1 and then put +1. Okay. Okay, I think we have everything. I can return the end position and the link. Okay. If I don't find anything, I return -1 and, for example, empty string. I think it's over. Let's try it. Get link. We have content. What's the name before? Page.content. Comma 0. I start from the beginning. The first link we find it's print. What's happening? The first link we find is in position 79 and it's a self-referential link. Let's search for a link in position little after. Okay, there is a link here to one of the university icons. There is an empty link here, very well. At exactly the link we find above. There is a link to the Master of Software Engineering Information Systems. Okay, so you can see we can get links. We can get one link at a time. Okay. Now, I would like to get all the links. How can I get all the links? Well, obviously, the strategy here to get all the links is, first of all, let's copy the procedure. It's not necessary because it's already in the computer memory, but let's copy it to have the full code here. Okay. Now here we can build a little program to get all the links. How can you do it? You build a while loops which goes on until this one, until the first argument, which the first thing which this one returns is not -1. So you do a while loop, which calls this one with the same page, and here the end of the previous link. Okay. Let me also copy this one just to be sure. So I have all the code in the same thing. So the procedure, this one. Okay, sorry, we don't need to print. Now, n equal to 0. N is where do we start from. Okay. Now, try to do it yourself. It's really extremely short. You have to call get link, get the result, put the result inside n, and an URL, a string, print a string, and then go on until n is not -1. When n is -1, you stop. So stop the video and try to do it alone. Okay, we'll do it together. While we'll see later. Okay. Okay, at the dots must be filled. So I get link and n. No, first n and then the link. From get link page dot content comma n. I think it's over. Okay, let's see how does it work. So here until n is larger than -1. So we start from 0. We start from the beginning. Okay. We get the link starting from 0, so we get the first one, and we'll put here the index of the first one, which is approximately 76, and here the link itself. We print the link. Okay. Then we go up here. So if n is not -1, so it's larger than -1, we'll go on. Okay, so when you arrive at the last link, we'll get it and get all of the last link. Then we arrive at when there are no more links. At this point, n will be -1. This will be empty, so it's pointless if we print it or not. Okay, and then the while loop will stop. If you want to be precise, you can do if n larger than -1. If you want to be precise, but it's not necessary, you will print an empty link. Okay, so if you have not grasped how does this work, I am addressing in particular to those of you who have problems in figuring out abstract programming. If you have not grasped how does it work, please try to do it with your own fingers. Let's say not on the entire university web page, but just on the very beginning, so up to the second link. Try to do with your own fingers, and you will see how does it work. That's it. Run. Takes a while to load the page, and it starts to print the links. Can you see? All the links of the web page until the last one. This is the last one, and there is an empty link here. You may immediately see that we got a problem. Yeah, a big problem. Because some of the links are fine. This one are fine, even though they refer to the same web page. Okay, but we can't do anything about that. But they are fine. Okay. Some are duplicated. Okay, we'll deal with it later. Okay, these are fine. However, there are links. Can you see? Which don't start with http://www. This is because these are internal links. So they don't start like this because this part here, it's, let's say, taken for granted. Okay, but I would like to see http or https://www.unibz.it here in front. So now we'll find a way such that if the link does not start with HTTP, we'll put the HTTP inside. So we'll put this thing here in front. So let's copy everything. I copy everything every time. It's not necessary to copy everything every time, but just to have the complete program here. Okay, so we have to build, for example, a procedure called fix internal link. This procedure takes an internal link called L. It will return the internal link fixed. Okay. Address. Okay. So it will attach the address, which will be this one. Okay. So we modify a little bit the program. Address equal http :// Okay. Now, so if L does not start with HTTP, how can we say that does not start with HTTP? Well, it's easy. L of colon from table H is a position 0, T position 1, T position 2, P position 3. We say HTTP or do we go on? No, just so 4. Okay, so it means from 0 to 3. Okay, if it is equal to HTTP, it's fine. So we have finished. Return L. Else, sorry, I forgot the colon. Okay. If it doesn't start, we have to attach the address in front. So return address plus L. Finish. It's finished, but there is a little problem. Now let's see here, instead of printing the link, we will print the fix internal link of link. Let's see. Fix internal link, fix internal of link comma address. Let's see whether it works. Yes, seems to work. We have a problem, however, which doesn't appear in this web page, but may appear later on. Not all the internal links start with a slash. So, for example, the internal links I write on my web page most of the times don't start with a slash, start directly with themes, for example. Okay. This means that we have to distinguish here. If your address ends with a slash and the part of the link that you have starts with a slash, you have to remove one of the two. If your address does not end with a slash and the link does not start with a slash, you have to put a slash. In all other cases, it's fine because you either have the slash on one side or on the other. So, we have to elif L 0 equal. Where is the slash? Alt Shift 7 and end in Python is end. Address. Oops. No, the slash is on the other side. Okay. And address of -1, the last character of address. Equal. In this case, I have to return address from the beginning up to the second last character plus the link. Okay. Elif in the case that both don't have the slash, I have to return the address plus the slash plus L. Okay, I think we have finished. Okay, so I just fixed this thing for the people like me. Okay, let's see whether from my Paolo Coletti works. Okay, yeah, it works. There's a mistake. String index out of range. It means that I have a link which is totally empty. Can it be? So I have an href totally empty. Okay, well, to avoid it, I just use this dirty trick. Okay, you know that when you... sorry. Okay. This is exactly the same as L of 0. Okay, but in this case, I am sure that that does not give me an error, it gives me an empty string. Okay. Fine. So few links I have. So it means that I have empty links in my web page. Fine. Okay, let's see the exercises. Very easy. Maybe they're long. Draw the flowchart of the program and the flowcharts of the procedures. I mean of the last program. So you have 2 procedures and 1 program. Draw the flowcharts. Thank you. Describe its complexity, considering as input a web page with n links. So consider your input is a web page with n links. Describe its complexity. Well, you have some comparisons defined. You can define as your complexity measure how many finds do you have to do. Okay. Also describe how many integral additions and how many comparisons. Okay, probably integral additions and find. Find for sure is the most expensive operation. Okay, video is over. Goodbye.